Alright, let's look at 6.2. 6.2, they say find S, and they give you the formula here. This is for compound interest. Okay, and remember N is simply M times T, the number of compoundings in 1 year times the number of years. And I is your interest rate divided by M, or the number of compoundings in 1 year. Alright, so they tell you, in 1A, they tell you S is 2,000. Actually, they don't tell you S is 2,000. They say S equals 2,000. 1 plus 0.02 raised to the 24, so you crunch it down and you get your answer. Which from this I was able to figure out that N is 24, R is 0.02, P is 2,000, and S is that. You didn't need to write that down, but I did. P equals this, and you crunch down what this guy is in the inside and raise it to the 40th power, and you get that. Write down all those digits. Divide both sides by 4 point that, and you get this number rounded to 2 decimal places. Okay, number 3 says identify the annual interest rate, the length of the investment, periodic interest rate, and the number of periods. So number 3 says 8% compounded quarterly, so 0.08. Quarterly means 4. T means 7. And the number of periods in the investment, or the periodic interest rate, is N times T, or 4 times 7, or 28. And your periodic interest rate, C, is, I did this backwards, Your interest rate is 0.08, your N is the compoundings in a year, which is 4. Part B is the length in years is 7. C is the periodic interest rate, which is R over N, 0.08 over 4, which is 0.02. And the number of periods is M, which is N times T, 4 times 7. Total number of periods over the entire loan is 28. Okay, same thing for this one. 9% compounded monthly for 5 years, so R is 0.09. T is 5. C is R over N, which is 0.09 over 12, which is this. And the number of periods is M times N, which is 12 times 5. Compounding monthly, so M is 12. Number of years is 5, so your answer is 60. Alright, this one asks you to find the future value when you have 8,000 is invested for 10 years. 12% compounded annually. So 10 times 1 is 10, so N is 2. N is 10. Okay, so you plug in 8,000. You plug in 0.12 over 1 raised to the 1 times 10. So that's 1.12 raised to the 10 times 8,000, and you get this number here. Number 9. What's the future value and the interest earned if 32,000 is invested at 8% compounded quarterly for 5 years? So you know T is 5, M is 4, R is 0.08, P is 3,200. You can figure out I because you know R and M. That's 0.08 over 4, or 0.02. And you know N because that's just simply M times T. 4 times 5 is 20. Okay, so P, 3,200. R over M is 0.08 over 4. MT is 4 times 5, so you get 1.02 to the 20th. Crunch it all down, you get this guy. And then they ask you, what's the interest earned? Alright, so if you started with 3,200 and you end up with 4,755, the difference between them is your interest. Okay, and number 10, what interest will be earned if 6,300 is invested for 3 years at 12% compounded monthly? So 0.12 over 12 is 0.01. T is 3, we know that, so M times T is 3 times 12, or 36. Okay? So you plug in all the things that you know. R over M, M times T, P. This is 1.01 raised to the 36, and you multiply it by that and you get that answer. The difference between the 6,300 and the 9,013 is your interest. Alright, so number 11 says, what lump sum do parents need to deposit into an account earning 10% compounded monthly? M is 12. So it'll grow to 80,000, so S is 80,000. in 18 years, so t is 18. Remember, n is simply m times t. 12 times 18 is 196. So you know your s and everything else, you don't know your p. So this is 1.008333333 raised to the 216. Crunch that out, raise it to the 216, you get this. Divide both sides by that 6.004 number, and you get 1332.91. That's how much you have to start with to end up with 80,000 in 18 years. Okay? Number 13. Number 13 says, what present value P amounts to 110,000, is invested for 10 years at 6% compounded annually, so M is 1. So M times T is N, which is 10. R is 0.06. P you don't know, S you don't know, or S you do know. So 10,000 P, 1 plus 0.06 over 1 raised to the 1 times 10. 1.06 to the 10, which is this number. Divide both sides by that number and you get 5583.95. That's your P. Number 14. Number 14, you've got 300,000 present value. Now I say what present value amounts to 300,000 in the future, so that's S. 7% semi-annual, so 15 years. So N is simply M times T, or 30. R is 0.07, S is 300,000. So you plug in everything that you know, figure out what this is, raise to that, and you get this number, and you divide both sides by that, and you get 106,000 something. So 106,000 something after 15 years becomes 300,000. 17, what's the compound interest if 41,000 is invested for 10 years at 8%, compounded continuously? So now this is a new formula. When they use the words compounded continuously, you use this one. Otherwise, you use this one. Okay, so 41,000, 0.08 times 10. That's e to the 0.8 times 41,000, and you get this number here. Now what's the interest? It's the difference between 41,000 and 91,000. It's 50,000 something. Okay, now 21. Which investment will earn more money, 1,000 for 5 years at 8% annually, or 1,000 for 5 years compounded continuously at 7? So 1,000 for 5 years at 8% compounded annually. So remember, N is M times T, or 5. So you got all these numbers you already know. Plug them all in. You get 1.08 to the 5th times 1,000 is 1469.33. So now this one, you use the compounded continuous formula, so all you need to know is P, R, and T, which you already know. You multiply 0.5 or 5 times 0.07, you get e to the 0.35, figure out what that is, times 1,000, and you get this guy. So this one earns you more money. So which one will earn you more money? It's 1,000 for 5 years at 8%. That's a better deal. Now 23, APY, or annual percentage yield for an investment at 7.3% compounded monthly and 6% compounded continuously. So if you've got two different offers, one's at 7.3 monthly and one's at 6% continuously, how do you know which one's a better deal? Well, this APY will take your situation and tell you what the interest rate is compounded annually for both situations. Now you can compare them and see which one's better. So you plug in your R and your M. Okay, notice there is no T because T is just 1 year. You're doing it over 1 year. And you figure out all this and you subtract one and you write it as a percentage, and it's 7.55%. Okay, so this one is just e to the R minus 1. And you figure out this one, write it as a percentage, and it's 6.18%. So that one's a better deal, clearly. But if they were comparing this one, for example, to something that's like maybe 7% daily, you wouldn't necessarily know which one's better until you did the other one at 7% daily, converted its interest rate, and compared it to that one. So that's the only way you can really compare interest rates, is if they're both compounded in the same way annually. All right, 32, you've got $10,000 and it's worth 46 something. What interest rate compounded annually? So n is 1 for 10 years. T is 10. So n is simply m times n. M is simply m times t, sorry. You don't know the interest rate, and you do know everything else. So you plug in all the things that you know, and everything you know except for r. So you got all this equals 1 plus r to the 100, or to the 10. Divide by 1,000, 10,000. You get this equals 1 plus r to the 10. Take the 10th root of both sides. Another way to do the 10th root is raise it to the 1/10th power. Okay, and then you subtract 1 and you get this guy, 1.93, which is 193%. That's a very good interest rate. 33. How long in years would $700 have to be invested at 11.9%, so 0.119%, compounded continuously to earn $300 interest, or give you a total of 1,000. So 1,000 equals 700 e to the 0.1119t. Divide by 700. Rewrite it as the log. Log base e of this equals the exponent. Divide by 0.119, and you get this. T equals 2.9973, or roughly 3 years. Alright, 37. For her first birthday, Ruth's grandparents invested $1,000 in an 18-year certificate, 18 years, that will pay 8% compounded annually, so m is 1. How much will the certificate be worth on Ruth's 19th birthday, so 18 years later? Okay, so you know all these numbers already. Plug them all in and simplify, and you get $39.96. So $1,000 18 years later is worth roughly $4,000. 38. 38 says to help her son buy a car on his 16th birthday, the boy's parents invest $7,500 on his 10th birthday. The investment pays 9%, compounded continuously. How much is available on his 16th birthday, or in other words, 6 years later? Plug in everything you know, crunch it down, and you get that much money. 44. Suppose Patrick deposited $1,000 in an account that earned simple interest at an annual interest rate of 7%, left it there for 4 years. Okay, so his interest would be $280, and the amount that he would have at the end is $1,280. At the end of the 4 years, he deposited the entire amount from that account into a new account, earning 7% quarterly for 6 years. Okay, so 6 years, 6 times 4 is 24. Your original amount is P, the amount that comes from the previous account. So the ending amount from this account becomes the starting amount for this one. And you plug in everything you know and crunch it down, you get 1941.05. Okay?